Today we are looking at scatter plots and best fitting lines. Scatter plots are graphs of points that are scattered. So scatter plot means exactly that. It's plots, points that are scattered. Scatter plots allow you to determine whether there's a relationship between the two sets of data. For example, if we looked at, for a full week's time, how many pairs of shoes were in my closet on each day, and used that as our X values, and then for our Y values used the chance of rain. Do you think the number of shoes in my closet and the chance of rain are related data values at all? No, it does not matter if it's going to rain or not. I'm still going to have, I'm not even going to estimate how many pairs of shoes are in my closet on a daily basis. Now, if it was something like percentage of the sky covered with clouds compared to chance of rain for the day, do you think that those data values might be related? Yes. There's 3 ways that the data can be related. We can have positive correlation, negative correlation, or no correlation. If a scatter plot shows positive correlation, the points are going to generally follow a line that has positive slope. As the X values increase, the Y values also tend to increase. Think clouds, rain. As the sky gets cloudier, there's a higher chance of rain. That seems to make sense. Negative correlation would be the opposite. As the X values increase, the Y values are going to decrease. And I always struggle coming up with an example of this on the spot, so I'm not going to. And no correlation. If I asked you to try to draw a line representing the slope of these points, how would you draw that line? You would not know whether to draw it with positive slope or with negative slope. Some of you who are a little bit witty would draw a squiggly line connecting a bunch of the points and call it good, but that's definitely not okay. So if you can't tell whether it's positive or negative because it is so scattered, that would be no correlation. That's like the whole shoes compared to chances of rain situation. We're going to do this graphing the scatter plot and finding the line of best fit step by step. So I'll come back to these instructions after we've done each step. So our first step is carefully draw a scatter plot of the data. Use graph paper. And I want you to think about the scale that we are using on the graph paper, because you want your scatter plot to be as accurate as possible while still fitting on your paper. So if this is our data, we need to think about where we want the origin to be and what we want the scale to be. So in some of my classes, I moved the origin over to right here. Do you want to move the origin, or should we still use 0, 0? Let's still use the middle. So I am going to actually draw in my X and Y axis, and then I want us to think about the scale. Our X values are going from -2 to +5, but do you see all those 0.5s in there? It'd be really nice if we could count by 0.5s. So would that fit if we made this 1, 2, 3, 4, 5, our X values go up to 5, that works. You don't have to label all of these. I like to label at least the even numbers. And then we've got -1, -2. That's all the farther we need on the X's. For our Y's, we're going from -2.5 to +4. I think the same scale is going to work. So here's 1, 2, 3, 4, -1, -2, -3, -4. Okay, do you feel that you can take this graph with this scale and accurately plot those points? Go for it. if you're watching the video, pause the video, plot the points, then play the video again. Okay, so here's our scatter plot, and just glancing at this, does this data show positive, negative, or no correlation? Negative correlation. That's a good thing to kind of note. Now if we go back up to our directions, carefully draw the scatter plot, done. Step 2, sketch the line that appears to follow most closely with the pattern given by the points. This is called the best fitting line, and this can take some practice. There should be about as many points above the line as below it, and you need to try to equalize the space between the points and your line. You really want to think about what kind of slope are these points showcasing and try to make a line that matches that. So in purple, I'm going to draw in a potential line, and I want you to tell me if this is a line of best fit or not. First of all, I didn't draw a very straight line, which is bad. There's about as many points above as there are below, so what's the problem? Okay, we have to match the points better. Don't necessarily try to hit points, but also don't try to not hit points. Does that make any sense whatsoever? So don't try to hit them, but don't try to not hit them, basically. What I do is this, it's really nice if you use your ID because you can kind of shove your ID out of the way so you have like that clear plastic. Or if you have a protractor, like a clear protractor with a straight edge, you can see the points on either side. But try to move your line around, and if you're in class right now, you can see me doing this with my arm. This is not matching the slope. Is this more like matching the slope? Yeah, so try to draw a line through there that equalizes the space between the points. Make it fit. So let me try to do this on my screen. What about... How's that line? What? Where? Once you have your line drawn, and keep in mind your line might be very different from somebody else's line, you really just want to try to make it fit your data. So try to make about the same number below. I actually only have 4 points below the line, but the points that I have above the line are pretty close to the line, so it looks all right. Now we need to find an equation for our line. Now, is your line going to be exactly the same as my line? The chances of your line being the exact same as my line are very, very slim. So, step 3, this is the most important step. Choose 2 points on your line. Estimate the coordinates of each point. These 2 points do not have to be original data points. In fact, it's often better if they are not original data points. So as I look through my line, and this is where it's really important to actually use a straight edge and not estimate, but look at your line and find places, like see this one? Could we figure out what this coordinate is pretty easily? Okay, so those of you on the video, I'm pointing at this one right here. And then keep looking for another point that perfectly is on the line. And it's a really good idea to pick one point that's kind of on the upper side of your line and one point on the lower side. So I'm going to pick 2 points that are on my line. You pick 2 points that are on your line. So my points, I think I will use, this one looks pretty good. That would be -1, 3.5. And I want to point kind of down here somewhere, maybe this point, which is 3.5, -2. If you have 2 points, do you know how to find the slope, use point slope form, and write an equation of the line? We've been doing that for a day or 2 or so. So you have 2 points. Find your slope. And keep in mind, your slope may be slightly different than somebody else's slope. And then put it in point slope form. Distribute, get y by itself, get your equation for your line. And you may have decimals. That is totally fine. So using the points from my line, I found a slope. I got negative 1.22. Getting decimals is fine. This is very much real world because we're using all sorts of crazy data. And then I used my slope and one of my points in point slope form, distributed my slope, y equals negative 1.22x plus 2.28. There is a way to plug this data into a computer and have the computer crunch out what is statistically the line of best fit. And I did that, and the computer told me that the actual line of statistical best fit is y equals negative 1.11x plus 2.27. So is my line pretty close to the statistical best line? All right, now on a test or a quiz, how accurate am I going to ask that you be? Really, truly, on this problem, I care about the process. So if you show me that you can put the data values into a scatter plot, that's a point. Draw in a line that decently fits that data, that's another point. Pick 2 points that are on your specific line, not points that are close to your line, but points that are actually on your line. That's another point. And then use those points to find the slope and get the equation for your line. That's another point. So there'll be 4 points possible on this problem, and I'm really looking at the process. Usually I look for a range of slopes. Like if your slope is anywhere from like negative 0.5 to like negative 1.5, you're pretty good. Are you guys' slopes around there? Okay. If your y-intercept is anything from about 2 to 3, maybe even 1.5 to 3.5, you've got a pretty good y-intercept. As your slope changes, the y-intercept is going to be affected as well.